what's up guys? Here is your helpful video for handling the DeltaMath assignment 1.c types of discontinuities. So you're going to go ahead and head to this assignment, click on types of discontinuities graphically, and then it says the graph of the function f of x is shown below. State all values of x in the open interval -9 to 9 for which the function is discontinuous. So this one, it just wants you to tell me every place that there is either a hole, a removable discontinuity, a jump discontinuity, or an asymptote, a vertical asymptote, which would be an infinite discontinuity. And so we're just going to list the places, the x values that happens at. So we start up here, and that's a perfectly good point. There's a bunch of points along here, 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 here. Our first jump discontinuity is at -5. And then when you throw a comma in there or press a space, it'll go to the next section, and that's okay. All right, so there's my jump. And I follow, keep going, keep going, keep going. All right, jump discontinuity at 1. Oh, gotta hit comma apparently. All right, and there's my jump. We did it. All right, follow, 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 follow. Okay, good. All right, so I don't have any more, so -5 and 1 should be my only answers. Woohoo! All right, let's try another one. All right, so for this one, I'm going to do the same thing where I'm just going to go from starting from the left and follow this up. So points, 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 points. Okay, here my graph goes down for forever and then up for forever. So here I have a vertical asymptote, which is an infinite discontinuity. Now be careful, because this problem says for which the function has a removable discontinuity. So we're only looking for holes in this one. So an infinite discontinuity does not count. Okay, so then we're going to skip that and we're going to keep going. All right, here I have a hole. I pulled a point out, I removed a point, and I slapped it up there. I don't have to put it anywhere. If this point was gone completely, that would still be a removable one as well. So I have a removable discontinuity, a hole at x equals 1. And then I'm going to keep going, keep going, keep going, keep going, and I have a jump discontinuity here, but that's not removable. So my only removable happens at 1. Voila. All right, let's do one more. So this one says, for which the function is an infinite discontinuity. So this time we're only looking for where your graph has an asymptote. So nothing, 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 nothing. There's a removable, there's a hole. All right, nothing, nothing, nothing. Okay, here's a an infinite discontinuity because I have an asymptote right there. So I would say -1. And then we just keep going. Follow, 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 follow. There's another removable, but nothing, no asymptotes there. There we go. All right, let's see if we need to do one more. Okay, last one says, state all values of x for which the function is a jump discontinuity. So we want to look at wherever the function ends in one spot and then seems to start up in another one. So let's start at -9, keep going. There's a hole, but my function continues past that hole. So this is a removable. I just pulled one point out. Here is where I have a jump because my function seems to end at -5, right, at a y value of 0, and then it pops down here and it starts all the way down there. So that's where my first jump discontinuity is at. And then I have another hole here that was removed, but my graph didn't jump anywhere. Same thing here, hole where my point was removed, but I didn't jump anywhere. And aha! At 1, my graph seems to end up so high and then jumps down below. So it's at -6. Oh, excuse me, not the y value. Where does it happen? So what x value does it happen at? It happens at 1. And then the rest of my graph goes that way. Cool beans. All right, go ahead and get started on that. Hope I helped.